Okay, let's wrap this up. What we ended up with, if you remember, we had two equations using Newton's second law. The first equation governed the first block, 6 kilogram block. The second equation governed the motion of the 5 kilogram block. Now, remember, those two blocks are connected by that tension force, that cable. So they represent a system. So we're going to go ahead and put both equations together and answer the problem of what is the acceleration and what is the tension force. So I've done that here for you. This is the first equation that we had. Remember, this is as far as we could go. And this was the second one for the block, the smaller block, 5 kilogram block. Well, we're just going to go ahead and add these together, but notice we have a positive tension force and we have a negative tension force. Well, those are going to cancel each other out. Remember, the tension's the same throughout, so it's going to be pulling with the same force. One was pulling negative, one was pulling positive, so they cancel each other out. That is a nice situation. So what we end up with then is 49 newtons. We have a negative 8.8 newtons, and that's going to equal to 11A. So we end up with 40.2 newtons, just doing some subtraction, equals 11A. Solving for that, can't see it, the acceleration is going to be 3.7 meters per second squared. Now, that's my acceleration of the whole system. But what about tension force? Now I have acceleration. Let's look over here. I can go back and use either of those two equations that I came up with. The one that governed the motion of block, that's 6 kilogram or 5 kilogram block. I can use either one of those and put in my acceleration now, 3.7. And now I can solve for tension. So I'm going to use the first equation. Force of tension minus 8.8 newtons equals 6A. F equals ma. Net force equals mass times acceleration. If I plug in my acceleration, 3.7 meters per second squared, and I solve for force of tension, I get the tension force is 31 newtons. So 3.7 was my acceleration value, right down here. And over here, 31 newtons was the force of tension. I found this one, then I used that value to help me find that one. Again, I could put in the acceleration on either of those two equations and I'll get the same answer, or I should. All right, that's how we do this homework problem. That's how we use the Newton's second law of motion. Go ahead and work through it. And there is a second pulley problem for you to work on. It's on Schoology, and give it a shot. But after walking through this one, obviously let me know if you have any questions. But remember, we'll take each block separately. We'll do separate free body diagrams on each block, and then we'll write our, got to do it twice, I'll write an F equals ma equation to help me determine what governs the motion of each block. I'll add them together, both those equations. Typically, I can cancel out tension because one's going to be positive, one's going to be negative. It's always critical, though, to make sure you've got your positive and your negative motions right off the bat, which is why we did the free body diagram in the beginning. All right, this is Mr. Crowley, and I approve this message. Have a great day. Let me know if you have any questions or concerns.